Hi everyone. The motive of this video is to give the Terraform information with demo under 10 minutes. So what is Terraform? Terraform is an automation tool for our infrastructure. What is its advantages? We can make infrastructure as a code and also version control it using systems like Git. We can maintain state of infrastructure using Terraform. Terraform is cloud agnostic, means like it is supports both AWS, Azure, GCP, and also other cloud providers like DigitalOcean. It can be integrated with open source systems like Ansible. The topics we will be seeing in this course are about resources, Terraform commands, backend modules, outputs, provisioners, data sources with demo. So let's do the Terraform setup. So we will create IAM role EC2 instance S3 bucket and DynamoDB. Let me log into my AWS console. First, let me create role, IAM role. Let me select EC2 service. Basically, this role I am creating for providing it to the Terraform instance. Next, permissions. In the permissions, basically in the permissions, I'm attaching administrator access. So the instance can create most of the resources. So Terraform administration role. I'm copying it. I'm giving it as a row. So I'm creating row. So after creating row, I will be going to launch an EC2 instance. So I'm selecting base Amazon Linux image and T2 micro, which is retail eligible. I'm just selecting add storage and add tags. In the name tag, I'm just Terraform instance. In the security group, I'm creating it as a default security group. So one thing, in IAM role, we can select the IAM role which we have created, administration role, and then I'm just previewing and launching. So since no key pairs are found, I am creating one key pair. So I'm creating one key pair, and that's it. I'm launching one instance. I'm creating one S3 bucket also. To store this bucket is to store the state files. So I'm giving some random number and remaining as default. I'm also creating one DynamoDB table. This DynamoDB table 2 is used to lock the Terraform run. So its lock ID is we need to use as a primary key. And let's create. So this is the setup. Let me log into the instance and run this script, and we are good to go. So these are the instance on S3 bucket Dynamo resource results we just created for setup. Let us log into the instance. So I am using Mobax term for SSH into our Terraform instance. So I have keys, Terraform instance key pair already loaded. I'm doing SSH to a Terraform instance. Okay, I did SSH into Terraform instance. let me change the host name of this to Terraform instance. So this is how we made our setup. We will run the basic commands for downloading the Terraform file and moving it. Basically, we can write a simple shell script. Where we download and so let's verify. Terraform intentionally downloaded and installed Terraform 12 version. So now Terraform is been installed in our system. So let's go to the next. Okay, we successfully set up our Terraform. Let's check the provider. So whenever any resource or anything, any infrastructure to be created by Terraform, we need to mention provider, which provider. Since AWS supports different cloud providers like Azure, AWS, DataSource, many things. So you need to provide. Here we are using AWS provider, so we need to provide this block in starting off. Let me make one directory provider resource. So here what I'm doing is I am making one. You can name it anything, but .tf should be there, and you need to give that. I'll paste this code open. Basically, you need to provide this provider block. You can mention version also you want to fix. That's it. So we provided basically which we told Terraform which cloud provider to use. That is about provider, and basically the basic Terraform block provided is a resource. Using this resource only, the entire all resources from VPC to AEC to RDS, everything is present in this location, registry.terraform.io. But here we are seeing about the VPC resource. So the basic building block of Terraform is this resource only. So let's see how to create it. So just is vpc.tf. You can name it anything. VPC. Let me name resource, but .tf extension should be there. And let me provide the CADR block I have provided. See, since I am copying, just be careful to. As you can see, this is a JSON format. That indentation doesn't matter, but if you want to do indentation correctly, there is a Terraform command. Basically, Terraform fmt. Okay. Then if you see correct pattern is provided. The structure is maintained. So this is a Terraform resource. Okay, this is a building block. Let's see how to basically run the VPC. Basically, create the VPC. So these are the basic commands and the most used commands. These are the useful to be recognized. So basically, Terraform init. Basically, what it will do? It will initialize our providers. See, it downloads all the plugins. It initializes providers. It initializes our Terraform scripts. If we provided any modules, I will discuss it later. It will initialize that also. So we initialize it. Next command is Terraform plan. Oh, I think it's not visible. Let me clear. Terraform plan. Terraform init, Terraform plan. We see Terraform plan. It is showing one to add. That is basically it is showing AWS VPC resource. This will be created. If we do Terraform apply, it will ask us yes or no. If we say yes, so it is creating on VPC. Or we can verify in the Terraform console also. So if my screen is visible, then let me open VPC. In the networking sessions, it will be present. See, networking and content delivery, or you can search in the services session also. So it's already 11 minutes. Let's see. We can concerns. So if you can see, it created one VPC. Or let me cancel your VPCs. I'm in Oregon region where which I have provided. So let me provide Oregon region. So Terraform destroy will destroy this VPC. Let me show you this Terraform resource in Oregon region. So this will delete the Terraform VPC. In the provider, if we mention region as US West 2, let's apply. So this VPC is created in Virginia region. Now I will be showing one VPC. It will be created in Oregon region. See, here there is no VPC. This is default VPC. Now see, one more VPC is created. 0D is 3B. I think it is visible. So here if you see, it is 0. Okay, 0D. Okay. You can see 0D. Same VPC ID is created. That's about. So we have seen Terraform provider and Terraform resource. Now we will see Terraform backend. So backend, if you see, these are the state files. Terraform generates Terraform state basically. So it contains all the information of our what is being created, like VPCs, what are being created, these entire things. But problem is, if we haven't stored them in a proper manner, if 2 or 3 people using as a team, then it may create a conflicts and issue. So the better way is to use S3 as a backend. So let us see how to use the S3 backend. If you remember, we already set up one S3 bucket. So we will be using that S3 bucket and DynamoDB for proper backup. So let's name can be anything, as I said before. Just a .tf should be there. So since this I'm copied from the code, so these are just the ones. So right. So if I do Terraform init, basically it will ask initializing the backend, the path to the state file inside the bucket. So we can create a state file inside the bucket. Let's say I don't want to give any path, so I just want to create. So the error is due to the region we are specifying. We are specifying wrong region, so it is giving error. So after fixing that region, after fixing the region, if I run it again, I will show you the file again. After fixing the region, if we run it again, use S2, it will ask us whether we know copy the backend to this. So it is copying the backend. So backend copy is done. We can see the backend copy in S3 bucket also. This is how the backends are shifted. Now if we see ls, so backend will be the provider and VPC resource we have seen. So let's continue to the next implementation of modules. So basically one important thing I want to share. Basically the backend.tf, it contains these keys. These we can't use the variables here. We need to fix it. Key is nothing but if we specify like the key, this is the folder it will create if it is not present, and this is the file through which it will upload. So and DynamoDB table, as I said previously, it is for logging. So here we can't provide the variables. That is one important thing. So to show you S3 bucket, let me show you S3 bucket. So this is our S3 bucket. Oh, so for clear, let me, I think it is not clear for you. Let me show S3 bucket. So I think it is clear, visible now. So this is the S3 bucket where infra is the folder it's automatically created, and this is the object terraform.cf. If you open the file, it will contain all information of our VPC, everything. Okay. So that is about backend.tf. Let's go to the modules. Modules are like efficient way to use the code. Basically, they are as a form as a layer over our resource block. So I will show you the demo. There are two types of modules. Private modules is the one which we create over our own resource blocks, and there are other public modules also. You can get the repos from GitHub Terraform module repos. So this is the GitHub link. You can go through and you can get the popular modules. And for the using public modules, you need to mention the proper source. I will explain you in the demo. So let's see how to use the modules to ease our code and to ease our management of Terraform code. So there are two types of modules basically. Private modules. I will tell you about outputs and data source later. Let's complete about our modules. There are two types of modules: private modules and public modules. Let's see how the private modules are formed. So let's see the demo for private modules. So private modules, the structure. We will go directly into the demo. The structure, as you can see, is as you know, the host name is changed just for convenience. So the structure is like this. We have backend.tf, which we already seen, provider.tf. So these are the new files and folders which we will going through the structure to know the structure. So first, let's see what is present in a VPC module. So if we see the VPC module main.tf, the module contains nothing but a resource. the resource block which we have defined. Basically here only one thing, if you observe, instead of fixing the variables CADR, we use variables. So by seeing variables.tf files, it will be more clear. So if you can see, so previously when we are using resource.tf only about the resource, we have all the variables inside the resource block defined, predefined, but here we are just defining variable and leaving it. So when we are using the modules, actual modules, so this is how we define a module. So when we use this actual module, what it will do, it will refer this resource, which is VPC module, this folder. Since this folder contains two files, main.tf and variables.tf, and remaining every variables of these file resources are set except VPC CADR, so that VPC CADR will pass as a variable in our module. So here the advantage is we no need to write the entire resource block again. So we just mention, we just write this part of code module and VPC CADR, we just need to mention. So this module layer will invoke this VPC.tf, which is a module, will invoke the VPC module resources, resource blocks, and give us a output desired. Let us initialize. So it will be downloading and Terraform plan. So if you see the Terraform plan is saying the same exact resource Terraform, it will apply with the same CADR, everything which we seen earlier as a Terraform resource. So if we do Terraform apply, it will apply basically. So this is about the modules, how to use modules and what advantages modules at what cost. There is another concept also, public modules. Let's see the demo of public modules. Basically public modules, they basically we will get the code from GitHub repos, as we mentioned. There we mention, let me make a, so after clicking yes, I won't be doing this because anyway we will do together. If we see, let's say public module, public.tf, seeing my screen is visible. So source, if we mention directly source as Terraform AWS modules, it directly download from the GitHub. So in here we placed our absolute path, so it will download from there. But if we mention directly Terraform AWS modules like this, it will from GitHub, and the GitHub link already provided before. Version you can mention version. These are VPC CADR, these things. We can make it in the variables, or we just mention. So I will use the variables and I will show you the exact code. So let's see the public modules demo. So the code is just became a very simple one. So let me go to the demo. So here the difference, if you observe, there is no a folder structure, no nothing, resources, nothing. So the under resources block, I will explain you where they are found. So they are found in .terraform folder. So basically the code became very easy now. So if you can see source, it will directly download from this one GitHub. So this is the code. Basically the variables, as you know, I define variables.tf, and their values I define in terraform.tf was. So these are the values I have given. You can refer in the code. So basically when I do terraform init, this very important thing to remember. So the module public modules. So basically one more thing, if you haven't installed git, there can be an issue. So you know the command is sudo yum install git. So I already have installed, that's why in my machine it is already installed, that's why it is not giving an issue. But if Terraform now if we do ls -ltra, there is a .terraform folder. So here in the modules there is a VPC module. So here we have defined basically all the basically it copies the files resource blocks from the GitHub, and we can view those here basically in the main.tf. So basically this is the main folder. If I open the main folder, so this contains all the resource blocks. So basically the public module is referring that GitHub and driving the resource blocks, and on the top of it it is building modules, that is all about public modules. If I plan it, you can see there are number of resources created. So basically what it will create one VPC, number of 3 subnets, how many subnets you mentioned, CIDs. Is it basically the information you get from that GitHub readme file? But I'm just saying, since VPC module is a popular one, so if we provide only these are the variables we need to provide, remaining everything it takes care. So what, according to the code, what it will do, this is a normal code block we use for the VPC setup. I mean entire network setup in our major architectures. So here VPC CADR you need to provide, with public CADRs you need to provide. If we provide 2 CADRs, it will create 2 public subnets. Private CADRs it will provide, so it will create 2 private subnets. VPC region and availability zone, these are the things only you need to provide. And according to the code, basically if we public subnets we are referring, so it will create the public according to the public area, so it will create 2 or 3 public subnets, private subnets also. These are the important. Enable NAT gateway. If we enable NAT gateway, it will create NAT gateways and automatically attach to the private subnets. And DNS source name, if we make it true, then it will enable the DNS source name, which is very useful when communicating via Route 53 domain names and cross domain names. So it is useful to maintain this set of blocks true and false. So this is a common set of block and common piece of code which is used majorly in many organizations. So this is all about public modules. So in a way it creates 20 resources with minimal code, and it is very easy to reuse. That is how it is. That is why it is very modular structures are very popular. Now let's see about outputs. So outputs are also important thing. So these are used to refer in basically it will output. I will show you in the demo. Basically they are used to output the variables for our view case. So basically if we output make this output, and if we do Terraform apply, after creating the resources, those resources IDs which we are referring will become automatically as a output in our screen. Later also we can use them using Terraform output command. We can refer those output variables. So those, like in the context of referring the variables, the outputs are important. In the modules it is important because we use data resource, which I will come across later. So generally data.tf in data variables and output.tf variables need to be present in normal scripts. So this is the about output.tf. You can read the further if you are interested, but it is not it is generally optional use case for output.tf. So data resource. So data resource is nothing but it will fetch the data. Basically, Terraform provides the data of AWS APIs in the form of data sources. So I can show you one example also. Let the Terraform apply happens. Later I will show you the example. Basically, it will by defining this and in the output edges we are saying like data dot availability zones, this one, and available names. So it will give all the available names particular of that region. We initially specified region provided, right? So it will fetch all the regions. Like since we specified US West 2, it will provide US West 1A, US West 2A, like that 1B, like that it 2B, like that it will give us the availability zone names. I will show you in the example also. So this is about data sources. Then null source and provisioners. Basically, provisioners, there are three types of provisioners as mentioned: file provisioner, and local provisioner, and remote execute provisioner. So I think this is a remote execute provisioner. So what these will do is like a file provisioner, it generally copies files from source to destination. It makes a connection with the whatever the host, and it will copy the files from source to destination. So and this is null and local execute will execute a command in locally. I will show you this in demo. And a remote executioner will run the commands inside the host missions, like target missions. So this is about null resource and provisions. And it took around 30 minutes, but the content, if you take the Terraform, it is explained under 10 minutes only. I mean approx 10 minutes. So that by that note, I will show the demo of outputs.tf and data resource, and I will see outputs.tf like this. It will provide the output. Later, if we want to use see output Terraform output, it will show the outputs generally, that is. And I will show you the demo of this data resource and null resource, and I will close the basic session. So basically after this, I basically I made one complete end-to-end project for creating database cluster, cockroach DB, if you may heard of. So complete end-to-end creation using the entire things which we learn in this exercise, in this lecture. We can do that as a project. I have done that as a project. I will explain in the next video. If you are interested to know the special use case, you can watch that video too. I will provide the link also. So data source I have provided, right? Let me check whether the semicolons and everything are right. Yeah. So if I do Terraform apply, okay. So basically the since semicolon issue this, okay, issue 6. If you see data and output, if I do Terraform apply, it will show the ages like this. So the data resource is not useful for small things. It is very crucial part, and even in the extracting the backend also, that I will show in the next video demo. So like this, it will show the ages also, because we define output in a data source output ages. Okay. Now let's see about null resource. .tf. let's create null resource.tf file and let's close this session. So let's do this one. Basically, one important thing about null resource is it will be executed once only. To execute it many times, you need to specify basically triggers. So if you want more interested, you can refer the next lecture where I will show the null resource creation directory. But this is a small demo. Basically, what it will do, it will so locally it will execute command. It will, if there is any shell script, it will execute shell script. It will use this as an input, and basically it is creating one file. Basically cat. This is how we basically create one file. Okay, sample file one. Let me do one shell script. So or just let's remove this. Let's make the things easy. Let's make one sample file one by executing this Terraform apply. And I just apply it. Okay, this is basically we need to do init because it need to hope you saw that file. Let me check resource again. Okay, make it setting. So this is just a file. We provide a provisioner. The code is already present, so it just will create a sample file by applying it. Basically, the issue is like it is referring from other file. That's why. So basically, I am just adding these two lines: server IP addresses and 107.109. These two lines I am adding I am creating in this sample file. So if you see the sample file is not there, but when I do Terraform apply, this null resource will execute, but once only, and it will create the sample file. Null is provisioning. If I do ls, there is one sample file. See, sample file, server IP address, this one. But if we execute again, it is showing two changes, but these are with respect to names only. So that null resource, that addition of null resource is not able to see if you observe. So we need to provide a trigger. Okay, this is the end of this lecture. It took around 35 minutes. So hope you guys got the Terraform in a easy and understood manner with the demo. So yeah, that's it from my side. Bye.